Okay, so it's August 25, and that's what we have for today. You know, I'll start with this. I'll start with this because I did take the test, and as usual, I failed it. That's my usual exercise the first time, but I'll take it again. That's not a problem. So I'm not making it to the Qiskit advocates, but then Qiskit advocates is for the benefit of IBM. Certification would be for the benefit of myself. So, of course, you know, if I pass, I would say, oh, great, it's very easy. But I can share some of the impressions of the test. So for that, we need to open the right repository. Let me give it the right repository. It's here in the Quantum Computing Lab, and I'm giving you the link first. I think it's a good thing to try for the test, or at least to prepare for the test, because I would say that's the most authoritative organization as far as quantum computing. And so therefore, source. And I have to say that I'm a little late, like a couple minutes, just because I was doing it, finished the test. Okay, so let's go. If we go here and I give you the link, but I will also give you that link on chat. So here is our chat. Okay. Then the place where you'll go to is the very top, right here. And it says Qiskit Developer Certification Syllabus and also study guide. So yes, I would say study guide is the most useful. And in the study guide, you can pass through the few introductory slides. And one of the things you really need to gain is the intuitive understanding of what that does. Because there would be quite a few questions on the Bloch sphere, and you need to understand what those numbers mean. I have to say that I wasn't perfect on that. I don't have an intuitive understanding. I really need to do it better. There will be a question like, what do you need to do if your vector shows down below? Okay, and or for example, what operation will not change the state of this vector if it is starting here? So that's one. Another one is that anything you study there will be good, because some of the questions. So let me turn this off. Some of those questions will be in areas you will probably never touch. So, for example, it asks a question about what happens if you ask for a specific device in a specific geographical area, and then you want to plot a map of your qubits to the device. So you have no idea, because you probably never were interested in plotting the map of your qubits to a specific device in Australia, for example. So because of that, anything that you learn will be useful. That's another thing. And probably the third advice is that they are not malicious. The guys who composed the test, they're not there to trick you. And for that reason, I got 53. I should have gotten 73. That's in points. In questions, there are 60 questions, and I got about half of them answered. Now, in that case, half is a pretty big number. because many of the questions will be like choose 1 out of 6. And that is, if you do it randomly, and 1 out of 6 will obviously be 13%, right? And if I got 53, that means that it's not as hard. And another thing is sometimes they ask you to give them, choose all that apply, and there are 3 out of 6. So the random probability to get that right is close to 0. But they're not malicious. You can read the questions attentively, and that will give you a lot. Okay, so what I want to do is just come to a few questions. And let's start with this one. For example, what statement will create a quantum circuit with 4 quantum bits and 4 classical bits? All right, now I'll let you answer, because now I'm not the only one talking. By the way, I'm going to the participants. Okay, and I'm allowing everybody to talk. All right, thank you. And I will also make sure that you can all chat. Everybody can chat to everybody. Let's see, where is the chat? Chat is right here. Okay. Testing chat is good. Now, what I also need is, yes, everybody can talk to everybody. Is your answer. So out of these, which will be, and that does happen on the test. So which is the right way to say 4 quantum bits and 4 classical bits? I know that Aisha gave the right answer last time, so she can do it again. Well, hey, okay, all right. You did it last time as well. Yes, that would be the right way. Now, how can you know? Maybe by default, quantum circuit 4 and 4 also gives you the right answer. So, and that's a bit more complex. That would assume that you need to give the parameters as an array and not 2 separate parameters. Well, the only way to know is to prepare. Turns out that it is 8. It could have been, except a very complicated way of doing it, C, it could have been anything. So that will be a good way to learn. How about the next one? Okay. And given this fragment of code, what is the probability of measuring 0? Okay, so let's try to reason about this. We are taking a regular qubit and we are rotating, that's R, it's around the y-axis. And for that, you need a really good picture in your mind. Where is the x-axis and there is the y-axis. And, well, and 3/4 of pi, that's how much. So it's almost the complete pi, but you're going on the y-axis. So the result will be either C or A, because half of the 0.5 answer would work only if you rotated half of the pi, but you did 3/4. And one wouldn't work because you didn't do the complete rotation. But so it's either A or B. I wonder, what will you say? Question 2. C. So you're thinking it's C, and I think it was C the last time we looked at that. And that is what you need to have in your mind to get the right answer. This is 0, this is 1. The question was, how is it probable to get that particular probability close to zero. On that picture, right away, you see you're pretty far away from zero. So it could only be 0.14, right? And let us see, what does he say? Yeah, that's your qubit, and that's the equation, and that's 0.14. So that's the kind of exercise. I'm not going to go through the rest of that because you can do it. I gave you the link, and if you're interested in playing with this certification, all right, I lost my voucher, but I'll have to do it another one. So eventually I'll announce that done. Okay. That is what I promised to do. That was this one. Another one is what's new. And we will look at that. And then finally, we'll do an exercise. And I found out that my way of doing the exercises are the best in general and in particular to prepare for the test. And when I say my way, it's not really my way. It's the same notebooks that I got from them, but running it locally is much better. So I will show you all of that. Okay. Now let's look at the news. What are the interesting news there? Visualizing mysterious dance. Why don't I get pictures underneath? Researchers visualized a novel technique and they can see their particles. So I don't think that adds much to our understanding, but nice pictures you can share with your friends and you can say that's the wave function and that's what it will look like, but I can't even see. So that's probably what they see. All right. No, I couldn't get much interesting stuff. Now I'm also talking to Intel. Remember, I'm a member now of the community, how you do this. So all of that is nice. Now, the last thing that I promised was another exercise. Let us do that. Let us do exactly that. And that is because it doesn't quite work on IBM. So no, let's go back for a second. And so here we have all the preparation, but let's go to the IBM link. Here, right? No, doesn't work. All right, let's find the IBM Qiskit textbook. All right. All right, that's the course. And what you can do here is start learning. And you will go through the regular exercises. Let's go the 8 of computations. And what I want to come to is the actual exercises. They are here. And theoretical at least, I like the format. I like how they do a reminder. If you don't know or forgot how to do those gates, they will tell you. And this is where you can run it. So let's try to run it. But you see, it says start kernel and run. Well, first of all, you're depending on their service now. And it's taking some time. So sometimes it's a bit faster, sometimes it's a bit slower. So, okay, you can do it. You can wait for a minute or two, and then you can run it, and then you will see the qubit. So let's look at what it does, right? But then we will look at a better way. Okay. So here we are. We're building a quantum circuit of 3 qubits and 3 regular bits, and then we draw it. Okay, so I would say, I would still say it's a poor man's way of learning, because that doesn't work perfectly well. Okay, again, you have to start the kernel, and you have to go back every time, because if you're in the middle of something, it forgets what you did. Let's try to run this. Okay, it runs. It builds a quantum circuit of 3 qubits and 3 regular bits, and then it says now measure them. And when you measure, you understand that 0 qubit is mapped to regular bit 0. 1 to 1, 2 to 2, that's natural. You could do measure all, and you can experiment this. So you see there are 3 qubits, and they're all measured, and that's all right here. You could do measure all. Let's try. You can actually change the code here. You can say take it out, and then you see measure all. No, it doesn't let you, like in the notebook, it would allow you to hit the tab, and then you're good. But no, I'm doing measure all. Let's try that. Right, it measured all. You could do this as well, and you can experiment. That's what I wanted to show. So if you have nothing else, that's how it is. But if you have something else, and that something else happens to be those open labs, what you can do is just clone them. That's the clone command for SSH if you have the key. That's the clone command for if you don't have the key. So let me demonstrate how you would be doing, right? By the way, check in the chat once in a while. So if you want to say something, the best thing is to actually say it, right? Like that. All right. But let's say I'm new to that. So first of all, I'm doing this. I'm saying code, copy that, open the terminal, make a temporary directory for now, then go into this temporary directory, okay, and git clone this repository to verify that this should work. Here I am. Okay, so ls will show you that yes, you cloned the directory, and okay. Now I already installed some of the packages, and I called them Qiskit, so I can do a quantum activate. And now I can do Jupyter Lab, and it should open these all labs, and that's where I will recommend you to start. Okay, so these are pretty good labs, and when I got them, they were all open. I could download them. Meanwhile, they slowly get out of sync, and it's a good exercise to refresh them. At least I do this. Now you can rely on me that I do that, and then you can run any one of them. I remember that last time I also showed how to upload them to Google Colab, and you could run them there. Yeah, that's another way. But don't you feel more comfortable when it's all fast on your local machine? It's the same code, so why not do it, right? So let's open any one of them, like representing qubit states, right? And it will be a good notebook. It will allow you to read all of that and explain all of that. Then find to come to the code. So here's the code. Let us do this. Let's kernel clean that all up. Okay, so it's all clear. And what we do is, first of all, verify that we have everything installed and it works. Now, if you, my impression of the test, so if you want to pass the test, pay attention to what it says here, because if you just run those notebooks, you have a tendency to just run it, like I'm here and I'm doing Shift Enter and it works. But they will ask questions about how do you spell it, plot block vector. And therefore it helps to that, inspired by the desire to pass the test. Now, let's look at some of the operations here, because it will be most useful if you do it, not if I just demo it to you. And you see, you create the very first quantum circuit, and it explains it here. The notebook says that's how you create the quantum circuit. So you run, you create the quantum circuit, and then you do something. For example, it all starts as at 0. But what you can do is take bit number 0 and set it to 1, right? I'm doing it here. So it is 0 and 1, and then I draw. Well, when you do it, play around, play with other functions. What else can you do? For example, you say QC, and since you're now in a good environment, you can hit Tab and look at all the functions that you can do. Let's look at all the drawing functions that you have. Draw, and then what can I put as a parameter there? Here are the parameters that I can put. But boy, that's hard to learn this way. So we will ignore that. I'm just showing that, yes, you can change things and learn by changing things around and so on. That's what I wanted to show you. And then they will show some wonderful diagrams. So if you want to go a little bit deeper than just running through that, well, you need to explain it. You need to explain it to somebody, right? Write an email to me, explain what you're doing. Of course, there is another way. That other way will be like this. You take that, you open ChatGPT, and you put the code in. Now ChatGPT begins explaining that to you, because it right away thinks that, the guy or the girl, she wants to get some explanation. So it gives the explanation. But by the way, my personal experience, you can convince it to explain anything. You say, no, that's wrong. You didn't do it right. I think I did it here, right? I said, no, that's not what I expected. He said, no, it's all right. It should have done this. And then I said, no, but I expected this. He said, oh, sorry, I'm making a mistake. It's very pliable. You can convince him in false and in true and all of that. That is the story, okay? And I only want to show you some additional stuff, some interesting additional stuff, and that is found right here. I was chatting to a friend of mine. That friend happens to be a mathematician in Michigan State University. So his name is Reinman. And down below, we were talking about something else. I mentioned that I'm learning this quantum computing, and I said amazingly, he is doing the same thing. So I told him that, look, first of all, I read all these books. And by the way, that's a good reminder. Here you are. If you are interested in good books, then that's them with some
I just borrowed the amazing book, The Amazing Quantum. Yeah, he's very good.
So let's do this. I'll show you that. I will also show you new books that he gave me, and then you will show yours. So here you are. Where that's, and that will stay here. We'll say books. So first of all, that's the link. That's my blog that I collected by listening to some of the lecturers at Qiskit. But then he gave me something else. That was right here. I told him that I'm listening and reading this book. And by the way, that is awesome book. Let's maybe talk a little bit about that. I will put it here. It's a new book and it will attract attention. Let's go there. All right, that's the book. Now, the amazing story about this book, and I don't think I've showed that to you, is that it was published in the year 2000, and it was written a little bit before. And we all know how things are progressing very fast. They're moving very fast in quantum computing. So when he wrote it, none of that existed. Nevertheless, it is a bestseller from the time it was published and until today, and it's great. All right, and that's what my friend confirmed, that he also thinks it's an amazing classic. So it was published around 2000. That edition that you can get is 10th anniversary edition. In other words, it was republished in 2010, just as good. And then modern commentary, another 10 years and a bit more, it's still just as good. So that's an amazing book. I have put it here, right there. And another thing that he gave me is right here. No, not this one. That's the one. So what I will do is I will simply put it here. That's us. And that's one more. So let me move it a little bit by this guy. And let's format it nicely. And that's for you guys. Now, this book, the Quantum Computation, you can get a PDF of that. I don't want to really publish this PDF of that because probably that's not nice, but I found it on the web without any big problems. So if you want a PDF, just ask me and I will email you that. That is an open article. That's very mathematical, but if you're into this, it's great. And so that I have printed for me to read at leisure. Okay, that is the theory today. The theory is that we get more and more stuff to read. Now, you wanted to say something about. Okay, I gave everybody a chance to chat, so you can tell us what other books you read, what interesting and amazing things you do, and in general, why do you study this quantum computing? I'll start the discussion with saying, but with me, it is some kind of I cannot get rid of it. You know, I can't stop learning. I started getting interested when I promised a company to teach them, and I taught them, and that was great. But you can always go deeper, and for a year, I kept going deeper nonstop. So why do you learn quantum computing? Let me put it in the chat. Okay, so Lawrence, you're reading James' book. And that is James, that's a different book, different James, right?
He's the author of the book, yeah. He's a different book, yeah.
Different, right? So let me do this. I will copy this and I will put it here for all of us. and give the credit. I will reformat it a little bit. But he is talking about another book, right? Here. Okay. In any case, thank you for that. I will look at it. The Mike and Ike, if you want to sound professional, you call this book Mike and Ike.
Yeah, I have that one.
Yeah, so Mike and Ike is also on the web. If you look for the author of that book, was right here. So if you look at Michael Nielsen, you will find Michael Nielsen here, YouTube. And I think I even have his channel.
Yeah. Yeah, it's just it's nice to get like
Michael Nielsen, there you are. And sorry to interrupt you. Yes.
That's okay. Yeah, just nice to get the overview of quantum mathematically free, and then later on go into the maths, put the maths, just get the high concepts, learn those without any mathematical formulae. So yeah, and then go into the weeds later, just getting into equations and stuff. Yeah.
Well, so can I ask you, why do you learn it?
Learn, yeah, just the interest in quantum from the very beginning, the history. Just I'm fascinated with the philosophy behind it. A different
Which
world.
part of philosophy?
Yeah. So with the Niels Bohr coming up, the early people that discovered, the Compton effect. This is all with the Oppenheimer. So I'm looking forward to the movie Oppenheimer.
Yes,
I
I'm
visited
reading the book about Oppenheimer, the whole thing on which the movie is based.
I just visited the Atomic Testing Museum in Las Vegas museum, and that's really good to watch.
Yes,
they're
you're
very
really
good
into it.
to
Yes, yes, amazing, right?
Yeah, so quantum has been around for a long time.
Yes, and I'm sorry that I'm just putting this all without asking. But I will rearrange it. I'll make it more like a regular seminar. That's what I would call our meetings, a seminar. Just like Oppenheimer. They
Yeah,
call him
it's just
he had these seminars.
going around the philosophy of penetrating, breaking the stone, going deeper and deeper into breaking something, penetrating.
Yes. I'll tell you what I was amazed. In the book, it talks about a transformation of a man who maybe managed his seminar, 20 people, that's all, to a person who had to manage 20,000 scientists and became an excellent administrator.
Wow.
You'll see that in the book, in the movie.
Yeah.
All right, so it's fascination, it's holding on to you, it doesn't allow you to to drop it, at least put it this way. If it's not taking all of your interest, but it's taking a lot of your interest. Guys, anybody has anything to add? Because that's very interesting. Okay, and of course, my own personal interest is the philosophy part, in the sense that I'm a scientist. Let's say I'm a scientist. Let's imagine I'm a scientist. But I'm bumping into mystical. I don't want to acknowledge it. I don't want to agree that it exists, but I'm measuring it. I'm measuring the mystery.
Yeah,
I can't
just
avoid
like
it, right?
it's just the thing, like if you like the square root of -1, the square root of -1 does not exist.
Yes.
But mathematicians created it. It equals I.
Yes.
And that has come up with uses in electrical engineering, etc. And there are many other things, many other concepts that have been created. The concept of zero as well.
Yes, but much beyond that, e to the power of I.
Yes, I love that.
That was last time that we discussed. How can
Yeah.
you take something to the power of imaginary number? Well, they showed last time they showed, yes, it's amazing.
Yeah, and complex analysis, conformal mappings, going into the Reinman tensor,
Okay, well, this
mathematics,
time, well, when I talked to this guy, Wahlberg,
Reinman
he
geometry.
said that his interest was in the same area, and same area for him means Hilbert spaces. So Hilbert spaces are multidimensional, and
Yes.
that is not a big deal. We're used to multidimensional, but it is multidimensional in the complex numbers. And that's already something interesting. So I found a book. I'll be reading that too.
Yeah, excellent. Yeah, non-Euclidean spaces, were created because, they needed a solution.
That's amazing, Lawrence. Okay, guys, I think we shared our amazement. We'll bring something new next time. I'm sure we will, because we have so much to investigate. And here's a failed attempt to pass the test on what I'm teaching. But you said the truth. The truth is, when I'm teaching, the first time I always failed anyway. That's how I worked with Google Cloud. And finally, I passed that too. And I got a car license holder, which says Google certified. And since then, I never taught this Google Cloud anymore. But no, I won't stop. I'll keep moving. I'll keep taking tests, and I'll keep inventing something new. All right. So that's it for today. Tell me if you want to discuss something else. Maybe not. All right. So next time I'll prepare more exciting subjects and we will discuss them all. Right now, I'll say goodbye to everybody and wish you a great weekend and then a whole great year in front.
Thanks, Mark.
Thank
Bye-bye.
you very much. Thank you for coming here and thank you for participating.